Hi Math 3, this is Mrs. Keener. So you need to make sure that you have the sound on because you will not see my face. Sorry about that, but I use a microphone and make sure your sound is on. Some students do like to use subtitles so they can kind of read what I'm saying, and make sure that you pause the video whenever you want to. So this is for Math 3 Honors. It's going to be the summer assignment, and we're going to start, when we start school, we're starting with Unit 0. And Unit 0 it's kind of like review. We need to get all on the same page before we move forward with new information. So this is the first lesson, 0.1, but again, we're doing this in summer. These are going to be notes. You can hand copy this onto lined paper, or you can print this out and then fill it in with me, and it's up to you. I do use colored pens and or highlighters, so if you want those to match what we're doing, you can use that. Maybe I'll work on my color coding this year. Maybe we'll do pink and blue for this one. Okay, can you guys all see? Everyone good? I only have 15 minutes for these videos, so I usually run out of time and it gets a little crazy at the end. But I like that we only have 15 minutes because it keeps them manageable. So you ready? The first, these are notes for this first summer assignment packet, how to solve linear and literal equations. So here we go. Before we review how to solve a linear equation, let's discuss how to recognize a linear equation. So far, you've only really solved linear and quadratic, but in Math 3, this is where we're going to solve a bunch of different equations, and you need to keep that all sorted out in your head. So a linear equation has an x to a power of 1, and that's it. All right, so that would be a linear equation. Do you guys know what makes a quadratic equation? A quadratic equation has an x squared in it. It may or may not have an x. It may or may not have other numbers. A cubic, well, what does cube mean? Do you know what cubic means? It means x cubed. So x cubed, and that could have an x squared in it and an x and constants, or it could just have the x cubed. Now a polynomial is x to the 4 or more. And we will solve, this is all the things we're going to solve this year. So a polynomial would look something like this. Let's see how fancy I can be. Okay, so we'll actually solve that polynomial this year. A square, notice how I'm doing all the equations. And what is an equation? An equation has an equals sign, where an expression does not. An expression, oh, I hope that's spelled correctly. An expression does not have an equals sign. It's just like math terms. Okay, a square root equation. If the square root of x plus 2 equals 5, something like that. A cube root, so you'd have a little 3 in here. The cube root of 27x equals 1. I'm just making these up. An exponential. Okay, an exponential is when your base is a number and the x is in the exponent. So 3 to what power is 81, like that. Also exponential will be base e. E is a number in math. We'll talk about that second semester. Absolute value goes like this. Equals 5, something like that. The absolute value, we'll solve those equations at the beginning of the year. Logarithmic, say logarithmic or logarithm. A logarithm looks like this. It's fun. I'm gonna not, okay, that's an easy one. Okay, I don't like writing equations that don't make sense. Trigonometric, so you learned about right triangle trig, but this year we'll solve trig equations like the sine of theta equals square root 3 over 2, like that. A rational, do you guys know what rational means? Rational is a fraction. Look how teeny tiny I can write. A rational equation would be something like this, and you'd solve that. And then, okay, think about this, a rational exponent. What the heck? What's a rational? A fraction? So an exponent that is a fraction. So we'll do that. Those are all the things we're going to do this year. But to start, what are we doing today? Linear equation. So a linear equation just has an x and numbers. You should know how to do all this, and hopefully this is easy in review. How to solve a linear equation. Well, we're going to distribute, combine like terms, move variables to one side of the equal sign, and then use inverse operations to isolate the variable. We really need to get on the same page about the word inverse, because I have students think that the word opposite means that multiply and divide are opposites, and that is like bad. No, no, no. So we need to talk about these three words real quick. Okay, inverse operations is an operation that undoes another operation. So what's the inverse of add? The inverse of add is subtract. Subtract. And what's the inverse of multiply? That is not how you spell multiply. Multiply. Divide, right? Okay. What's the, those you should know. That's what we're like reviewing. Those should be very easy. What is the inverse of a square? S-Q-U-A-R-E. The inverse of a square is a square root. So those undo each other. Square root. Let's see, what else? Can't really do, same with a cube root. A cube and a cube root are inverse operations. So in class, if I go, what's the inverse of a cube? You just go cube root, like that. Let's see what else is up here. Okay, ready? E is the inverse operation of ln. I know, it's crazy. ln. It's called a natural logarithm. You also did, so in trig, you did sine. The inverse operation of sine is called arc sine, or inverse sine. So that's a preview. I'm trying to think, did I miss any? No, that's good. Okay, but opposite in math is reserved only to describe positive and negative numbers. So what's the opposite of 3? Negative 3, right? So that is an example. What's the opposite of 1/2? Negative 1/2. Let's look at the opposite of 2 is not 1/2. Okay, so these are not opposites, 2 and 1/2. 2 and 1/2 are reciprocals. So the reciprocals, 1/2, what's the reciprocal of 1/2? It's when you switch the numerator and denominator. That's 2. What's the reciprocal? Now, if you just have 4, what's the reciprocal of 4, you guys? 1/4, right? What's the reciprocal of 5/2? 2/5. So these are all reciprocals. Not reciprocal is when you say like 3 and negative 1/3. Those are not reciprocals, okay? They're opposite reciprocals. But reciprocal just means invert the numerator and denominator, and opposite means change the sign, and it could also mean if something is negative, then the opposite is positive. So the only phrases, what's the only thing up here that you could also use opposite for? You can use opposite for add and subtract, but you can't say divide is the opposite of multiply. That does not make sense, okay? All right, are you guys ready? Look at me, wasting all this time. So I'm going to do some examples of these, but I'm going to start with the hardest ones and work my way back. You should be able to do all these on the first few pages. So I left room, or you could be doing it on lined paper. Yeah, so are you ready? I'm going to start backwards. Let's go to 27 because, oh, I'm so excited to show you this. You might not have ever done this before. It's so exciting. Okay, everyone on 27? You can pause at any time. Solve each equation for the indicated variable. The following require some factoring. Now, normally you guys only know factoring like this. And then you go like that, right? We're going to do other factoring. It's fun to solve these equations. So, what are we solving this equation for? We're going to solve it for A, the letter A. So locate A. A is here, and A is here. So question, do we have to distribute? Distribute? No. What's next after distribute? move the variables to one side. Are they on one side already? Are the a's on one side? Yes. Okay, the next step is combine like terms. Now, we have two a's, but the things in front are not numbers. I'm going to go over here and show you guys something. If we had 2a plus 3a, what does that equal? And then you go, silly Miss Keener, that is 5a. Okay, watch this. I want you to think about it differently. Do you agree that a is in both terms and that it is a common factor, meaning we can factor it out of both terms? So 2a plus 3a could also say a in front. So we're factoring the a out. What would be in the parentheses? We took the a out of the 2, and we took the a out of the 3, and we get this. Now I'm moving down the paper. Now we have an a in front, and what's 2 plus 3? 5. Is a times 5 equal to 5a? Yeah. So do you guys see how combining like terms could also be seen as factoring out a common factor? We're going to do that here. Do you see how a is in both of these? We're going to factor a out in front, and we get a parentheses. Now we took a out of here, negative 5b a, but we took the a out. So it's going to be negative 5b minus 6k equals negative 4. The goal is to isolate a. So now a is being multiplied by this parenthesis. So to get a by itself, we're going to divide by this parenthesis. And we use it, we keep it all together. Okay. Oh, that happens. My lights come out and then everything changes, and I might pause and go here. All right, I'm back. So we factor the a out, divide by the parentheses, and the final answer, a equals negative 4 over negative 5b minus 6k. Isn't that neat? Okay, let's look at 28. I don't like this 2. What is the inverse of division by 2? The inverse of division by 2 is multiply. So I'm going to multiply both sides by 2, and we go hiya, karate chop. The 2's are gone on that side, and we have negative 2ua equals minus a plus 2b. And we're supposed to solve for a. The a's are on different sides of the equal sign. We need to move them to one side. So we're going to add the a to this side. We get negative 2ua plus a equals 2b. Now we're going to use this trick we did here. We factored. Remember, it says the following may require factoring. So if there's an a in both of these, we got to factor it out. Now we couldn't do that at the beginning because a needed to come to this side, but a couldn't move to this side until we got rid of that 2. Do you see it? Negative 2u plus, what happens when I factor the a from a? I get a plus 1. 2b. Okay, final answer. We're going to divide by the parentheses, and we get a equals 2b divided by what was in that parentheses. Okay, am I skipping my steps? Yes, here we go. Look at me. I'm dividing. Ta-da, cross off, and a is by itself. Do we have time for one more? Let's see. Do you have more of these, or is this the only 6? Oh, this was the only 6. I think you can do that one. I think you can do that one. This one looks silly, yeah? Let's do this one together. Oh, you could do this one by multiplying by 3. Okay, here we go. I'm down to the end here. Kx. We don't like that kx. So we're going to multiply both sides, kind of like cross multiply. Remember how to cross multiply? What was the point of multiplying? To cancel it? Ooh, what is going on here? See what happens when I rush? What are we solving for? X. So we need to move the x to one side. Now that x is on this side, on the left, you can factor it out and divide. And I'm out of time, but you're going to solve the rest and you have all the answers.